question is from GATE 2016, Mechanical Engineering paper, set 3, question number 30. An inextensible massless string goes over a frictionless pulley. Two weights of 100 Newton and 200 Newton are attached to two ends of the spring. The weights are released from rest and start moving due to gravity. Tension in the spring in Newton is dash. Let's look at the system. Now, if the weights are moving due to gravity, 200 Newton is going to pull the 100 Newton up. This weight will come down and this weight will go up. As the string is massless and inextensible, it cannot stretch. When 200 Newton moves downwards, because this is the heavier mass, when this moves downwards, 100 Newton will move upwards with the equal displacement. If we have x1 as the downward movement of 200 Newton and x2 as upward movement of 100 Newton, we know that x1 is equal to x2. As their displacement is same and this displacement occurs in the equal time, their velocities will be equal. And if there is any change in the velocity of 200 Newton weight, same change will be occurring for 100 Newton weight also. And that is why change in velocity, that is acceleration, is also equal to each other for both the masses. So A1 is equal to A2 is equal to A. We can show the tension in the spring away from the joint. So on this side, we have tension in the string T. Same is the value on the other side. Tension will be uniform throughout. Let's draw the free body diagrams of the masses. For the first mass, tension in the string is upwards. Let's mark it T. Weight 200 Newton downwards. Because this mass is moving downwards, the inertia force will act upwards here. So we can mark this as M1A. In the second case, tension in the string again upwards, T, 100 Newton downwards. The mass is moving upwards, so inertia force will act downwards. Let this be M2A. We can find out M1 and M2 just by equating the weight to mass into gravitational acceleration. So to find M1, we have weight 200 Newton divided by gravitational acceleration 9.81. This equates to 20.387. It's mass, so it is kgs. Similarly, mass M2 can be found as 100 by 9.81, half of the earlier one. It is 10.19 kgs. As per Newton's second law of motion, we can write down the equations of equilibrium for both the masses. So in the first case, we have taking upward positive T minus 200. Inertia force is also upward, so it is plus M1A is equal to 0. Let this be equation 1. In the second case, for second mass, we have again upward T positive minus 100. This time the inertia force is downward, so we have minus M2A is equal to 0. Let this be equation 2. We can equate 1 and 2 because both are equal to 0. If we equate them, T gets cancelled from both sides. And finally we get M1A minus 200 is equal to minus M2A minus 100. Rearranging this equation, we have A into M1 plus M2 is equal to 200 going to the right hand side becomes positive, 200 minus 100 becomes 100. From here we can calculate A, acceleration A, to be 100 upon M1 is 20.387, M2 is 10.89. Let's just substitute these. We have 20.387 plus 10.19. A is computed to be 3.27 meter per second square. Now using this A value, we can use equation 2. Substitute A, M2 is already calculated. We can find out the unknown, tension in the string T. Hence, T is equal to 100 plus M2A. So we have 100 plus 10.19 into 3.27. This comes out to be 133.32 Newton. All the forces that we summed up for equilibrium equation were in Newton. And that is why the tension in the string is also in Newton. Let's fill in the answer. The tension in the string in Newton is 133.32. To learn more about such problems on Newton's second law, you can refer to the NPTEL video, Problem Solving Newton's Second Law. CH22. It's from the course Physics by Professor Sanjeev Sanghi. I hope the solution will help you clear it out. Thank you.